So this is the Cambridge Primary Checkpoint for Math for the year 2021, April edition. So it is just very fresh, just from the oven. In this one, it says you may use a calculator. However, it is important to keep in mind we don't want to use it as much as possible. So we are going to begin with the first one. It says write 12/16 in its simplest form, right? So we want to simplify, and we can tell 12 and 16 have halves. However, I don't want to go just with the halves. I might divide by 4. Yeah, so it will be 3. It will be 4. And 3 over 4 is the simple form of it. Yeah, 3/4. Now, what did I divide by? I divided both by 4. Yeah, I cannot divide by different numbers. Yeah, 12 divided by 4 is 3. 16 divided by 4 is 4. Now, should I say this is 0.75? Nope, I better not, because this is telling me the simplest form, and it is not asking me to provide any decimal equivalents. Exercise 2. Write a whole number in the box to make the statement correct. Yep, oops. So we want to go with the second exercise. It says, so we are rounding this to the nearest 10. Yeah, so the 10 is this 6 in this example. So there are many different possibilities. Yeah, we can say 361, 362, 363, 4. Now, because if we round it to the nearest 10, yeah, we are going to bring it down. Yeah, 4, 3, 2, 1 will be rounded to 0, yeah, as bringing it down. However, we might say 359, 258, 257, 56, and even 355 will be rounded to 360 as we are rounding the 10th. Yeah, so it will be 360. We will take it to the next level as this is higher than 5. Or 5 or higher will make it to the next level. So any of the possibilities I just wrote will be correct. Okay? However, I will prefer to write, well, not to take a risk, 361 or 359. 59 will be my best option. Exercise 3. Write a number in each box to make all the fractions equivalent to 1/2. So we want to see 1/2. So it says 1 is the half of 2. 4 is the half of 8. If I simplify, I am going to obtain 1/2, dividing this by 4, which I divide there in the denominator 2. 4 divided by 4 is 1. 8 divided by 4 is 2. And it will be equivalent to 1/2, right? So this one is pretty simple. Yeah, so 10. So 10 is the double of, yeah, the denominator is the double of the numerator. So that's what we want to do. Then let's write it down. 10 is the double of 5. Yep. 4 is the double of 2. So 2/4 is equivalent to 1/2. And 3 is the half of 6. Yep. So all of them, any of them, will be equivalent to 1/2. Exercise 4. 4 oranges are needed to make a glass of fresh orange juice. Gabriela makes 24 glasses of orange juice. Write how many oranges she needs. So exercise 1, highlight what you want to get. Well, you might not highlight the paper itself, yeah, but if it appears in a mock exam or in another kind of exam, it will be good to do this. So she wants to make 24 glasses. It says 4 oranges are needed to make a glass, one single glass. So this is one glass requires 4 oranges. Now I need to make 24, or Gabriela needs to make 24. So I might say 1:24 as 4 what? Now I have to multiply 1 times what to make it 24. That's it, 24. So I have to do the same on the other side, and I have to say 24. 4 times 24 is what? Well, 20 times 4 is 80, and 16 makes it 96. So this is the answer. 96 oranges are needed. We got it? It is very important we pay attention to these kind of exercises, and we just somehow get the important information. I say somehow as we don't want to highlight the paper, which is not meant to be done during the exam itself. But anyway, I can underline it with my pencil. I can just make a circle around. Yeah, I can just make some emphasis about those words in my mind and get the information so I can get the right answer. Exercise 5. Here are some numbers. Now we have 12, 14, 16, 42, 80, and 96. Those are the given numbers. Use each one of these numbers to make the statements correct. 1/5 of which is which? Now, 1/3 and 1/8. So if I start just trying, well, it might take a very long time, and it is something I don't have in a Cambridge checkpoint exam. So I must find connections. I just cannot go 1/5 of 42 and then start doing multiplications, because, well, it will be time consuming, and although even if I am very fast at these kind of calculations, it is going to be too long. So I might take a look at the denominator. Now, notice that it is very simple because it's only one out of the denominator, one of the fraction. So this fraction is pretty simple because it will come fast to my mind, right? Basically, I have to divide by the number, by the denominator. So dividing it by 5 divided by 3 divided by 8. So now, another idea. These are fractions, and it is only one part of it. So it means there is a small number in this place, and there is a big number in the second position. Yep. So, well, as a matter of fact, we want to take a look at this, and we say 1/5 of a big number is a small number. So, well, actually it is the other way around. So we want to say 1/5 of this big number is a small number, right? So let's try with the 6. If I were dividing 96 by 5, it is not divisible by 5 because it finishes in 6, not in a 0 or in 5 itself, which happens only in one of them. And now I can tell that this is the most suitable, the most possible 1 to be here. Because if I divide it, I am going to have a divisible number, a complete divisibility rule completed here. So it is easy for me to do the division. Now, if I were dividing something by 5, I could say 5 times 10 is 50. So now I want to have the half of 80, 40. 5 times 8 is 40. Hey, I don't have 8, but I have 16, which is the double of it. So 16 times 5, it is going to be 50. 10 times 5 is 50, and 10 times 6 is 30. So I don't have to write this as a calculation I am making, but it just comes to my mind. And as it comes to my mind, I am going to say, well, it is very fast. And so I can tell 1/5 of 80 is 16. Now, this comes to my mind because I know the times tables. 5 times 8 is 40. 40 is the half of 80. It means if I multiply by the double of 8, which is 16, I am going to have the double of 40, which is 80, right? It sounds incredibly long when I am explaining it, but it actually happens in a couple of milliseconds there in your mind, right? So now, what did we apply? Divisibility rules, times tables. So multiply and you will succeed. Thirds, eighths. So we want to multiply by, we want to divide by 3, we want to divide by 8. Now let's check this one, 3. So what number multiplied by 3 will give me another? If I multiply 2 times 3, is it going to be 2? No, it is not. If I multiply 4 times 3, is it going to be 2? Hey, yeah, probably. Yeah, look at this. So 14 times 3, so I say 30. 10 times 3 is 30, and 4 times 3 is 12. 30 and 12 is 42. For the sake of the Lord, I got the second one. 1/3 of 42 is 14. How did I get it? Because I know I have to divide one of this by 3. And because I know I am dividing one of them, I also know that I am multiplying another. 3, which is the denominator, and it is very lucky that we have only 1 out of 3. So I don't have to do any other calculation, any further calculation, but I only have to multiply. And then when I multiply, it will be simple. 3 times 4 is 12. A number finishing in 12. Well, not 12 itself, because it is the smallest number. So, and it will be a bigger number, 42. Definitely it is like this. And so, because we already know the strategy, we already have a strategy, which is the most important. Now we say 8. 8 times something, and that's something, I'm out of possibilities, right? I already took these ones, so definitely 8 times 2 is 16. So I can tell 12 times 8, and this is 80, and 16, 96. So 1/8 of 96 is 12. Now, once again, because I am given an explanation here, it takes much longer than what we need. Yeah, but definitely it happens very fast in my mind because I am making connections, because I am trying to make to develop a strategy and not just to multiply and divide because it will take forever. All right. Exercise 6. Complete the partitioning of the number. What number is this? Read it in your mind. Huh? What number is this? Yeah, we have the comma here in front of it, right before the 3, right? Between the 4 and the 3. So how do we call the number? Yeah. So it is 604,375. Now, they are not asking us how to call it, but if we can name it, it will be much simpler. 600. Yeah, 600. Now, this number is just 600. It's 600,000, right? 600,000. So this is 600 and 1, 2, 3. 600,000 plus 4,000, well, is 604,000, isn't it? Now, 375. We got it? Yeah, so it's not that complicated. All right. There is not much to explain there. Use the symbols greater than or less than or equals to complete the following. Okay, 1 whole turn, 3 right angles. My mind, what are you talking about? Turn, right angles? Well, so I am going to give you a circle, right? And it says 1 whole turn. So we are talking about 1 complete turn. How many degrees are there if I start here and I go 90 degrees, 180 degrees, 270 degrees? Well, there are 360. In a whole turn, there are 360 degrees. But how many right angles are there? Well, let's say, there is a right angle here, 90 degrees. There is another right angle here, and we are 180 degrees so far. And this is kind of too rough. Oops. I want to make it much better. So, excuse me for not being super demanding with this, but I just want to make it clear. So over here we have 90 degrees, right? And there is 1 angle. So 2 right angles, 3 right angles, and 4 right angles. How many right angles? Well, it says 1 whole turn, 3 right angles. Is greater, is smaller, 1 whole turn is greater than 3 right angles. Because it's 360. 3 right angles are 270 degrees we are talking about. Okay? Now, 1 right angle is 90 degrees. Now it equals 90 degrees. Look at that equal sign. Well, better. And 120 degrees is greater than or less than 2 right angles. 2 right angles are 90, 180. 180 degrees in 2 right angles. It means 120 degrees is less than 2 right angles. We got it? The very exercise in which you want to use the calculator. So we invite your calculator to come in. Now, it wouldn't be important to have a calculator if we don't know how to use it. So, or actually, we don't know what to do with it. So this is a balance, and here we have an addition. Here we want to have another addition, so it will be the same value. So what is it that we need to do? We want we want to have this addition, which is 215. Yeah, well, actually 215 plus what? Plus 36. So it is 251. Now, once again, we don't want to write all around our paper. So whether we keep it in mind or we write it aside, we don't write it in the very paper. Yeah, 251. Yeah, so we want to have the same value here. So because I have the calculator, I don't want to go, well, saying, it might be this or it might be that, and I start, well, speculating. Yeah, what I'm going to do is that I'm going to say 251, which I already have there in the calculator, and I say minus 136. 136. And it's going to tell me it is 115, which is what I am going to write here on the box as the answer. This is the answer. Yeah. Why do I take this one and I subtract this? Because this addition, yeah, this difference actually, yeah, will make this addition be equivalent to this one, right? So once again, in our box, we want to write this sum minus this part of the other sum, of the other one, of the second one. So we have this result, and the result is here, 115. Let's double check. Is it right? So once again, I am going to say 215 plus 36. Yeah, here in this calculator I can see it is the numbers and it is 251. Is it equivalent to the other one? So I'm going to clear this, and it says 136 plus 115. Yes, I'm right. So I am done with this. Well, done with this first one. Now the second one and the third one, we are going to take a look at them at once. So it says now we have a subtraction and is equivalent to this sum. So we are going to say 179 plus 287 equals 466. Now, if I am adding these two, and this is the number, and the secret number, which I am going to write here, 466. Now, do not write in the paper. Do not write in your paper, and don't make this kind of reminders anywhere, okay? Write them on a paper side or something, but do not scratch your paper. You will have trouble because of it, and mostly because you are meant to use only pen for the sake of the Lord. So now, keep that number in mind. Yeah, keep it aside. And now, what are we going to do here? Yeah, so what number minus 158 will be 466? So what do I have to speculate? No, I am going to say 466 plus 158. So that's what I'm going to do in my calculator. I already have 456 there plus 158. Hey Alejandro, but it's not plus, it's minus. Yeah, this number we are going to get minus this will have to be this, because this is the number we want to get. This is the sum. It has to be equivalent to the subtraction. So we are going to come here. We're going to come here, and it says 466 plus 158 is 624. So 624. And that's what I write. And we are going to double check. And we are going to clear this, and we are going to say 624 minus 158 is 466, exactly what I want to have balanced. Yeah, this is the number I want to have here. So this is the result. This is the difference, 466. Now we have a balance. Got it? Let's go for the last one. Now we have decimals. Interesting. So it says, here we have a subtraction. 95 and 5/10 minus 16 and 7/10. Hey, but look, this is a point, and here they are giving me a comma. Well, calculators normally work with a comma, right? So don't get complicated there. Then how much is that? 78 and 8/10. So I need to have that number in mind. 78, do not scratch your paper, write it somewhere aside. Now, 78.8. So it says that's what I need to get on the other side. Now, on the other side, then I am going to use this number I already have, and I am going to say minus 36.6. Yeah. So this minus 36, 6 or 6/10. So it is how much? 42.2. So this is my answer, 42 and 2/10. Am I right? Let's double check. Let's clear all this. 42 and 2/10 plus 36 and 6/10 is, oh my God, it is right. Thank God. So let's keep on doing. That's it. Exercise 9. Write in figures the number 690,402. So look at this. Figures. What figures is, what do you mean by figure? Well, in Spanish is cifra. Yep. But what it means is I want to write it with numbers. Yeah, the number, the given number. So I want to write with the number symbols the amount they are giving me. Yep. So what number is this? 690,000. Yeah, 690,000. 402. Yeah. At the beginning, it sounds. I should have given you some time for you to think of it, huh? And then you will have done it yourself, and then you wouldn't judge it is that easy. I invite you to try yourselves and with some different numbers, and you will realize that at the beginning, if you don't train, if you don't practice, it takes, well, some time. 690,000. 690,000. 402. 402. That's it. Yeah. It is actually pretty simple, but you have to double check. Now it says exercise 10. We are going to make it a little smaller so we can compare this. Now let's see what this talks about. Jamila and Lily both count the number of pieces of fruit sold at their school shop in 1 week. They each produce a graph of their results. Now, I am going to go straight with the explanation, and I am not going to, let's say, give you the chance to realize about, because this is time on TV, you know, it's very expensive. So anyway, now this is number sold, yeah, versus fruit. So there is the graphs are absolutely the same in that sense. Now what we have to keep in mind, yeah, well, definitely the what they are selling is the same kind of fruit. Yeah. But here comes the most important thing you have to keep in mind. This goes in tens. 10, 20, 30, 40, 50. It reaches 50 units. Yeah, this is absolutely important. Instead of the other one, which is by fives, 5, 10, 15, 20, 25. The highest amount is not 50. The graph in Jamila's graph reaches 25. In Lily's graphs, it reaches 50. So it is actually the double of it. So we have to be really careful with that because they are giving us different units, well, different amounts, which at first sight might look the same, okay? So please, once again, be careful. Now, it says peers. Well, if you compare, well, the peers are different, but they are different because the bar graph is different. It says 10, and it also says 10. So they are actually the same amount of fruits. I mean, the same amount of pears in this case. Now let's see bananas. Bananas, yeah, this one is what? 20, 25. Yeah, bananas is 25. So the same amount of fruit. Yeah, apples. Apples, yeah, it goes up to 20. Yeah, and apples, it goes up to 20 again. Yeah, but we have to make a careful comparison because these bar graphs are the same height. At first sight, they are the same height. And in fact, they are the same height. I mean, yeah, if you take a look at this in this way, yeah, but this unit is, I mean, this graph is given with different units. Yeah, this is given by tens once again. Yeah, so there are 30 oranges. And in this one, how many oranges are there? There are 15 oranges. So notice they haven't made us any question yet. I haven't read the question. And without reading the question, I am already explaining you about. So you can realize all this. I mean, you're not going to make the numbers at once. You're not going to make the comparisons without reading the question. No. You read the question first. But before that, you are going to realize about this. Yeah? Are they given in the same units? Are they given with the same amounts, in the same scale? Yeah? This is 0 to 50, and this one is 0 to 25. Yeah? So definitely the scale is different. We cannot compare just how high they are, because then we are going to be making mistakes. Yeah? Let's read the question. It says, one of the girls made a mistake when counting the number of fruit sold. Write which fruit has different scores. So which is the fruit that has different scores? We already found it, all right? It is the oranges. Why? Because there are 30 and here there are 15. Now, I don't have to name those numbers. I don't have to name those amounts, but I have to be really careful. And then let me make this smaller so I can answer the two questions at once. Now, so which fruit? Oranges. Oranges. Now, exercise B. The shop sold 70 pieces of fruit altogether. Put cross to show which graph is not correct. So what we have to do now is what? It says sold 70 pieces of fruit altogether. Now, we are going to go for Jamila's graph. If there are 10 Now, 10 fruits. I am not going to say these bananas and these pears. No, there are 10 fruits, and 25, is 35. And 20 makes it 55. And 15 makes it 70. 55 and 15 is 70. Now, so we can already tell that the other one is the one that must have the mistake, but we can not just consider that. Yeah, we must double check, and we do it mentally. We are not going to take too long. 10 plus 25. Yeah, this is 25. So it is 35 plus 20. Yeah, 55 plus 30. Oh, once again, the oranges are giving me a hard time. So, well, actually giving Lily a hard time, yeah. So Lily made another mistake here, and she counted 70 pieces, but she is wrong. Yeah, Lily's graph is not showing me 70 oranges. Well, 70 fruits, actually. Now, put a cross to show which graph is not correct. Be careful, the question might say, put a cross there for the graph which is correct. Indeed. Yeah. Now, write a calculation to explain your answer. Well, you don't have to talk about this because we already know it is 70. It is correct. Yeah. They want to say, why this is wrong? How can you tell it is wrong? Because 10 plus 25 plus 20 plus 30 is not 70. Yeah, you can leave it like this, or you can write is not 70. Yeah, and then you will be good. Yeah, all right. You don't have to write this part. It's okay. Got it? So let's make this greater again, and let's look for the second question. I mean, question 11, not number 2. I meant the following question. Put brackets into this calculation to make it correct. So we are going to get parentheses here or parentheses here to make it be right for us to have a result of 116. So let's find out. Multiplication the first. 3 times 15 is 45. Plus 25, yeah, makes it 50, 70. Minus 4, it wouldn't be correct, huh? Then we want to make it bigger. So we might say this addition the first. Now it says 15 plus 25 is, we have to erase this 45. Yep. 15 plus 25 is 40. 40 times 3 is 120. Yeah. 4 times 3 is 12. So 40 times 3 is 120. 120. Okay, 120 minus 4 is actually 116. Now, why did I go straight for this? Because I know there is a big number, and these numbers are not giving me a big amount. So I have to make it as big as possible. How? Well, I am adding this first. That's why I place it in brackets. And then I multiply by 3. Okay? Solve parentheses first, and then you go for multiplication. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So, exercise 12. Write a common multiple of 4 and 5 between 50 and 90. A common multiple of 4 and 5. Now, there are infinity amount of multiples which can be common for the two of them, right? multiples of 4. 8, yeah, 12, 16, 20, 24, the times tables of 4, and the times tables of 5. Now it says between 50 and 90. Now, oh my God, what did I do? Where was I? Question number 11. Well, actually number 12. So now, once again, I know 4 times 5 is 20. I know 20, which I already named, is a multiple of both. And 20 can give me an easy idea around here, between 50 and 90. Now you got it. 20 times 3 is 60. So 60 is divisible by 5? Yes. 60 is divisible by 4? Yes. So 60 is between 50 and 90? All right. So 60 is one of the possibilities. 20 times 4 is 80. Now, 80 is divisible by 5? Yeah, it is 16. 80, by 5? Yeah, it's 16. And divisible by 4? Yeah, it is 20. So 80 is another possibility. I don't want to write two possibilities. I only want to write one. So whichever, I'm going to get 60. Now, is there any other multiple of 4 and 5 between 50 and 90? Well, you find it. I know you can. Number 13. Draw a ring around all the numbers that equal 10 when rounded to the nearest whole number. Now, if you were rounding any of these numbers and to the nearest whole number, so the nearest whole number means right to the left of the what? Of the decimal point. Yeah. So we say if this is 5 or higher, you might make the one which is on the left of it approximated to the highest one. So this one, it says draw a ring. So that's what we are going to do. This one could be. Now, keeping that in mind, keeping this idea that if I take this 5, it will make it higher. Well, it will be 11. And they are not asking me an 11, they are asking me a 10. So this is not. What about this one? Now, 6 is actually greater than 5, so definitely it works. This one, if you round it to the nearest whole number, and it actually has a 2, you have to round it down. You have to bring it down so it will be 10. So as a matter of fact, this works for my operation. If I am rounding it to the nearest whole number. 9.48. No, this one is not a 5, right? So I cannot. So I have 3 answers. Okay, so now once again it says write 2 factors of 48 that have a difference of 13. First of all, we want to know what factors are. What are factors? Factors of 48. Well, the factors of a number are those numbers which multiply will be 48, right? Which the product is 48. So we normally go for the half. 24 times 2 is 48. So 24 and 2 are factors of 48. So which are some others? Well, let's say the half of this times the double of it. So 12 times 4 is 48. Definitely the most common one, which is the half of 12 times the double of it, 6 times 8 is 48. Now, and they are factors of 48. Now, it says a difference. Difference is the result of a subtraction. So, when I subtract this number minus this other number, it is going to be 13. Two factors of 48 have a difference of 13. 24 minus 12, no. 24 minus 4, no. So any of them is going to work. Well, the thing is that we are missing another possibility, which is 16 times 3. How much is 3 times 6? 18 plus 30, which is 10 times 3. 18 plus 30 is 48. Now, how much is 16 minus 3? There you go. So, our answer is 16 on 3. Yep. At the beginning, it seems to be confusing because you don't know this vocabulary, because you don't exactly know which are those factors, so you don't have to skip any idea. Okay? Practice, practice, and more practice. Hey, 90% of the exam is about the times tables. Then, here is a square grid. Shade 2 more squares to make a pattern that has 2 lines of symmetry. Kids, remember, a line of symmetry is that line which cuts an object and it is congruent on the left and right, let's say, on the 2 sides of that line. So this line is congruent, did I say line? This side, this left side is congruent to the right one. It has the same shape and it has the same measurement. So now a rectangle has 2 lines of symmetry. Well, let's say that it might have more than 2 lines of symmetry. And there are 2. And actually, if I go like this in a diagonal, well, making it correctly, it will be another, but I don't want to get the 3rd line of symmetry because this one is just asking me 2 lines of symmetry. So where am I supposed to draw those 2 more squares to make this figure to have 2 lines of symmetry? Absolutely. Over here and over here. Yep. Where will the 2 lines of symmetry be? Here, one cut in the half, and what is on the right is congruent to what is on the left. And another one here, making the upper side congruent to the lower side. Got it? So, exercise 16. A triangular stamp creates a print with 1/5 shaded. So this is not drawn to scale. Now, this is a tricky question. When I was explaining this, we were talking about an operation. What operation are we going to work here? However, the answer sheet, which is provided by Checkpoint, by Cambridge, says the answer for this. It says write what fraction of the logo is shaded. So what fraction of the logo if we place we know this is 1/5, right? Once again, we want to take a look at this. So this is 1/5. What is shaded is 1/5. And now they create this new figure, and then they create this new logo. So if there is 1/5 over here and 1/5 over here, 1/5 and 1/5, how much of the new figure is created? Well, the answer sheet says 1/5. It might be logical just to say that no matter I place 10 of them together, the proportion is going to be just the same, right? This is not going to occupy any bigger space because I am using as a model here and here and here and etc. So no matter how many of them I use, it is going to keep being 1/5. That is the answer, 1/5. Now, exercise 17. Here are 4 images from nature. Now, tick the pictures that have at least one line of symmetry. So once again, talking about lines of symmetry, we want to find congruent sides. What is on the left is congruent to what is on the right. If I could be more precise, I would be showing you I am slightly inexact. I am kind of, oops, now I moved too much. So this figure, you can tell, is congruent on the 2 sides, left and right. Now we could have another line of symmetry like this, another one like this. So they are lines of symmetry, so this has at least one. There we go. Now, what about the second leaf? So whether I place it perfectly straight, I will tell that it has details on one side which do not appear on the other, and so it is not symmetrical. I cannot draw a symmetry line here. Now for this one, it seems that this one also has various lines of symmetry, like this, and like this one, and the vertical one. So no matter how many they are more than one. So this one will be. And this is spider web. Well, it has no lines of symmetry. It is not symmetrical. So we are going to say they are only these 2. You got it? We keep on going. Well, we want to go to number 18. It says, the rule for a sequence is double and subtract 1. Write the missing numbers. Double and subtract 1. Double and subtract 1. So if we got the double, let's say double of 2 is 4, subtract 1. Double is 6 and subtract 1. So 5. Double, which is 10, and subtract 1 will be 9. Double, which is 18, and subtract 1, which is 17. So now, it is not beginning with a 2. It is over here now. If it is subtract 1, the original number will be 14. And 14 is the double of what? The double of 7. We got it? Now, what is the double of 49? 49 times 2. Now, what is the double of 49? So we have 80, 96. 98. Sorry, 98. Minus 1. 97. And that will be how I have to complete this. What do I have to do? Understand the instruction very well. Read very carefully and take it easy. All right? Make it patiently. Well, do not hurry, but do not take too long in any of them. Now, exercise 19, Mia. Mia fills 3 containers from a bottle of water. Now, everything is given in liters because we are talking about liquid, because we are talking about water, but it is given in mixed number, fraction, and decimal numbers. So we want to express everything in the same scale, right? Write how much water she uses altogether. So once again, give your answer in liters. So over here, what do we want to do? To convert everything into decimals, everything into fractions. Anyway, we have to give everything in liters. So it is pretty simple to convert this one into decimals. So I'm going to say this is 0.5. Yep. And this is 1 and 1/4. I know 1/4 is equivalent to 0.25. So it is 1.25. 1 and 0.25. Yep. Now I am going to add all of them together. Yep. So this is plus 0.5 and 0 and 5 hundredths. So this is, there might be a 0 here. So I have 10, I carry 1. This is 8. And this is 1. The decimal point in its position, it means 1.8 liters. And that'll be easy, all right? In this kind of exercises, notice that it says, provide your answer in liters. They are not asking you to use only fractions. So convert everything into decimals. That way might be the easiest one. Got it? Good. We move on. Exercise 20. Mike measures the temperature at midday for 2 weeks. Here are his results in Celsius. Now, degrees Celsius. So it says we have this set of numbers, and now we have to complete these statements: the range and the mode. So we have to remember range, the highest minus the least. The greatest number minus the least. So which is the greatest number we find in this set of numbers? 14, 16. Yeah, absolutely, it is 16. So 16 minus what? Minus the least. Which is the least number we have in this set? 9. Well, it is 9. How much is 16 minus 9? Well, 16 minus 9 is 7. So the range of the temperature is 7 degrees Celsius. Mode. Now we go for the mode. And it says the most what? The most repeated. The most repeated number. So which is the most repeated number in this set? Well, first sight, it seems to be the 12. 1, 2, 3, 4, 5. Yeah, definitely there is no other repeating as many times as the 12. So 12 degrees Celsius will be the mode of this set of numbers which are giving us a temperature. All right.